Okay, thank you, everyone. So now the webinar is being recorded, and I would like to invite our first speaker, the coordinator of the project, Professor Fabrizio Granilli, to give an introduction and also set the scene for this webinar.
Thank you, Amrita. Thank you, everyone, for joining us today. So the purpose of today's webinar is to discuss about what we achieved in the framework of the HORSE project. So I will be the first to speak as the coordinator, and I will introduce the subject and our project goals. And then we will have more technical presentations about the results that we achieved. As Amrita said, there will be time for Q&A, and then finally I will close with some few final remarks. So let me start the presentation by discussing a little bit about a topic that we all know today is very relevant, that is cybersecurity, since our project is focused on this, on solving this problem. And as you see in this slide, it's very well known that cybersecurity is becoming probably the first problem in general in IT today, and it's becoming more and more one of the strategic pillars that are necessary to have a reliable business in IT today. However, it's a very complex problem because it involves a lot of transversal technologies, and cybersecurity itself is a continuous cycle of protection, detection, response, recovery, and then everything again. And as some people from Cisco said, there are today only two types of companies in the world that has been breached, so they have cybersecurity problems, and those that have been breached but they don't know. So in practice, it's a real threat, and it's also very complicated to know how to protect from that. And just to try and to be a little schematic, cybersecurity represents a very interdisciplinary topic because it involves, for example, today a lot of geopolitical issues, but also regulatory requirements, and it has direct impact on, for example, the supply chains interdependencies. And from the technological viewpoint, we are witnessing increased sophistication in the cyber attacks that sometimes is related to the gap in cyber skills because several companies that maybe are not experts or where that are not focused directly on ICT, they might have gaps. So not considering or underestimating this issue, but also with the advent of AI and the continuous development of technology, it's becoming increasingly complex to be aware, even just theoretically, about which are the threats to our systems. However, security attacks are a reality, and they involve all sectors. For example, here I took statistics from the area of transportation systems. That is one of the areas that we consider in the project. And here you can see that the highest majority of attacks is distributed denial of services that are very aggressive kind of attacks that are extremely evident, but also very difficult to mitigate and to avoid. So what happens if we consider the current scenario in the networking area that is dominated by the transition between 5G and 6G, so the sixth generation of mobile networks? 6G is expected, as usual, to bring improvements in the performance, like lower latency, higher peak data rate, higher spectral efficiency, and so on. And to do that, it will be required to introduce disruptive technologies in the networking and in the service delivery aspects. So 6G, as also 5G before, is expected to address a wide plethora of applications, and each application has different requirements, different configuration needs, and different services required from the network. And here you can see a few examples on the top. And this fact increases the attack surface of the systems today because we have to protect not only the 6G architecture itself from physical or direct attacks, but also we need to protect the applications and also the technology that we use in 6G must be secure somehow. And this problem leads to an increased attack surface that is extremely dynamic because also the already with the advent of 5G, but even more with 6G, networks are becoming increasingly softwareized and virtualized, and this makes the type of attacks extremely unpredictable. Here you see a recent survey, just as an example, where it's clear that there is no part in the system that can be considered immune from security attacks. And the kind of security attacks that you see in the second column is widely ranging from denial of service, that are probably the most popular and the most expected attacks, but they go even from man in the middle to data leakage to eavesdropping to false identity, adversarial attacks, traffic profiling, even attacks directly to the softwareization, like SDN, controller attacks, and so on. So this means that as we evolve our systems towards 6G, there is the need to understand how to control and how to detect which is the attack surface of 6G. And the main problem is that this surface evolves dynamically. So, some years ago, we proposed the HORSE project, where HORSE is the acronym for Holistic Omnipresent Resilient Services for Future 6G Wireless and Computing Ecosystem. And we worked on these problems for 2 years, for 3 years, from January 23 to we will finish at the end of this month. And our activities were in the framework of the so-called SNSJU group, that is a specific section of the European Commission that is focused on 6G. Just a few words about the project. The project, as the name says, is focused on a holistic approach. So we try to maintain a global vision of the system at the different layers. And what we propose is to integrate novel strategies for predictive threats and also to be able to detect, predict, but also evaluate the impact of security actions in order to help the systems to be more independent somehow and to have some level of automation that makes them more manageable even from the security experts. The technologies that we integrated in our systems are network function virtualization, intent-based networking, AI techniques, but also more emerging and most recent technologies like, for example, the network digital twins. And the idea is to develop a framework for protecting the system and make 6G secure, but also to validate our technologies in two scenarios that are one related to extended and augmented reality that you will also see in a video later on during the presentation, as well as in one more different scenario that is the future of transportation systems. The consortium is built from several partners that come from all over Europe. As you see, we have partners from Italy, Switzerland, Germany, Spain, Portugal, Greece, and Cyprus. And we have a mix of companies, research centers, and universities. Just to clarify better what is our purpose, we are focused on these five challenges. One is to achieve a holistic vision of the 6G system. The second one is to orchestrating end-to-end security solutions even top down and bottom up, so from coming from different angles from our system, but still providing a human-centric approach to security workflows, so to enable our decisions and the mitigation actions to be checked against policies and human intentions. But also, we want to engineer the system to be able to evolve itself. So the main feature is to have a dynamic system for detecting and even predicting threats that is capable of identifying the best mitigation actions to delete attacks or mitigate them as much as possible. And this system should be able to evolve over time, but also be extendable as new threats are known and provided to the system. So this means that we organize our work across several objectives. And the first one was to understand what is 6G and what are our potential scenarios. Since when we started, 6G was far from being even started. So the idea was to start from 5G and related issues and to understand how they might evolve with the next generation of mobile networks. Then to identify which are the required end-to-end security modules that we need in our system while maintaining the focus on the development of a human-centric, holistic, and distributed system capable of providing security in 6G mobile networks. To achieve this, we deployed AI technologies that enable to have a predictive approach to security management, as well as also to enable very quick detection and reaction, so that our system is capable of even predicting the impact of attacks, but also of mitigation actions, so that it's capable of understanding potential problems, but also identifying the most appropriate solutions for the security issues. And this is done by introducing several components that will be explained after my presentation, but mostly are related to the introduction of digital twinning. That is a technology that is emerging and it has a very important application in security, as you will see, but also to provide intent-based approaches that implement the concept of human in the loop. And finally, what we aim to is to demonstrate and to validate ORS technologies in real use cases. So even though the TRL level of the project, being more focused on basic research, is limited, we still achieve the deployment of our technologies in real use cases so that we are capable of understanding the problems related to engineering the system towards real utilization. And last but not least, this event also is one of our dissemination and promotion actions, because one of our purposes was also to make the community aware of potential issues in cybersecurity for 6G, and also to explain what we learned during the project and what are the solutions that we believe are the most appropriate for the situation. The result is what we call the horse functional architecture, but that will be explained in the next presentation by Xavier, that is our technical manager. So I stop here my introduction and I leave the floor to Xavi for a more technical description about our work.
Thank you, Fabrizio. Xavi. Okay, Xavi is here.
Yes. Let me say it in full screen. Okay.
Perfect. Thank you.
Okay. Thank you very much. Thanks, Fabrizio. To just give the room in the right point, right? So let's start. Okay. So I mean, as you said before, right? I mean, what is very important just to start to this sort of say security provision is try to understand where we are, right? And where we are is this sort of context, right? At the end of the day, as you say, we want to provide this sort of 6G security provision into this 6G ecosystem. So we should clearly understand where we are. And actually, when we started the project, say 3 years ago, and even now, we are in that point where the 6G architectural definition is yet an ongoing effort, right? So from this point of view, I mean, if there is no architecture to protect, there is no problem to solve, right? On the other hand, as you also say, Fabrizio, the attack surface is yet an open issue. I mean, we are adopting new technologies, we are adopting many different things that could be engaged into the 6G ecosystems. So this means that there are new attacks or new incidents that may come up. So this means that the attack surface is something that is open. So we should try to understand how we may face with these new attacks and also how we may provide a solution that is not, I mean, is not constrained to 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 have no idea how to manage these attacks that are completely new, right? Then we have the problem on the technology adoption, right? So even from the technological point of view, as AI could be, but also from strategies that also, for example, network exposure, that also opening the path for new incidents to attack. So the impact should be somehow considered. Also, we are working on a distributed ecosystem. So this that somehow we should go for something that is quite related to a software approach, a software layout. And also 6G is something that is not, I mean, isolated. Is also as a mobile network is also communicating with other different networks, trying to engage with that. So setting this sort of new paradigm that is kind of network of networks. And finally, I mean, clients of this 6G ecosystem will be clients that will run services that will be very, very, very highly demanding. So at the end of the day, reactivity, we're talking about security, is not an option. We should go for something that is much more efficient than going for a solution that is reactive. So these, say, six, just to summarize a little bit, these 6 points are creating a sort of uncertainty in the way that we provide this security. So what we try to do in force, of course, as Fabrizio was saying before, is try to provide a solution for security, right? For 6G ecosystems. So at the end of the day, this solution should be easy to manage, should be holistic, and basically from the conceptual point of view is based on three main ingredients, right? The first is, as I said before, we should not go for a reactive solution. We should go for something that is proactive as well. We should go for a sandbox scenario where we can test what is going to happen. And we should also go for an intent-based approach that is something that is easing the way that we interface, we humans interface with the system. This is extended in the project with two real-world use cases that are those that we included in the contract. We additionally added 8 internal demos just to facilitate understanding. These internal demos were created ad hoc just to show specific functionality of the whole solution, and basically how the components of the whole solution that are included in the system may also or should also be managed to reduce the chances for this to be open doors for security breaches. And if everything is perfectly cooked, we have the recipe to build the objective. So conceptually, we started with an architecture that is based in this picture. That it would be the previous one to what Fabrizio has shown before. So there are 3 main blocks. The first is the one on the platform intelligence layer. That is the one on top of the picture. That is mainly responsible for intelligence systems. So it's the one that is managing all that is intelligence related. The second one is the intent-based interface, the one in between. Is the one that is serving as the interface for network control, right? And the third one is the one that's responsible for security provisioning. Easy, right? So we have how we access intelligence and security provision. How do we manage that? We manage that in this functional architecture that is just a mapping of the previous one that is more, say, conceptual. And this is the one that we are now developing, or we have developed into the horse project. We see that there are different, say, clusters of components grouped by color, and we will now just very, very quickly try to go into each one of them. So the first, working on the left, is the one that is the smart monitoring. Smart monitoring is, as said, is the observability hub. So it's the one that is collecting all data that we need to manage the system from the point of view of monitoring how the system performs. This is generating a lot of data. So we have, before these data to be forwarded into the horse system or horse mechanisms to provide security, we are processing this data just not to feed the whole system with enough data. In parallel, we also have a block, that is this one on orange, that is the one that is responsible for all that is related to data management, right? What do we have? What do we have is two key blocks in here. One is the real context, and the other one is the one that is below, the threat prediction and impact. And this is related to how we detect and how we predict, right? The two different strategies that we are following first. The first one, the real context, embeds a system that is detecting and mitigating engine that is detecting and mitigating potential attacks. So it's responsible for real detection on the system. The second one, the emulated context, is the one that is responsible for predicting. So while we have real context on top and we predict, we detect, we have the emulated context below where we predict. This one is based on this sandbox that is supported by a digital twin that was mentioned also by Fabrizio before. And the idea for this component is twofold. The idea for this component is not only to predict when an attack is about to come, but it's also to predict what the impact of this attack may be, and also to estimate what the impact of any action to be deployed in the system will have in the system. So the idea is that we will not deploy an action, even if either the action is preventive or is a mitigation action. We will not do that unless we know for sure that the outcome of the action would be beneficial for the system. Look at, since we are working on prediction, we are working on estimation. So if we are estimating, this means that we may fail. So it could be the case that the action that we deploy is even worse than doing nothing. So that's why here we should analyze what the impact of the actions to be deployed is going to be before these actions are deployed. Okay, then this sandbox is also fed. I mean, since we have the network digital twin, but we need some representation of the attacks that are expected to say be incidents on this digital twin. And we have here the early modeling, that is a component that is modeling the attacks that are expected to, or that potentially would be incidents into the system that are feeding this digital twin. Okay, so once we are predicting or detecting an attack, the next step is to go on the green light, on the green color, right? The next step is to see what to do, right? And this what to do initially is managed by this distributed trustful AI engine, that is the DTE. The DTE looked at DTE is just delivering an intent. So the DTE is saying, hey, there is a problem in the system, so the action should be taken. I have no idea what the action should be, but you should do something. And this something is translated into an intent. This intent is feeding the block that is below, but also the block that is below is fed by the outcome of this common knowledge base. This common knowledge base is just the repository of mitigation actions or preventive actions. It also includes the generator of these actions, right? So with this information, the intent-based interface is the one responsible for generating a life cycle of actions that would be also represented as a high-level intent of actions that should be deployed into the system. Once this is done, we move to the deployment. The deployment is this blue one. And we start with this reliability, trust, and resilience provisioning. This is the one that is responsible for mapping these high-level intents that are embedded into the life cycle that is delivered by the intent-based interface into real actions. The next component, the EPM, the end-to-end proactive secure connectivity manager, is the one that is responsible for orchestrating the actions. So when we know what to do, we order it, right? But before deployment, that would be the one on let me say again. Once these actions are set and they are orchestrated, then we go to the domain orchestrator connectors. That is the block that is responsible for transparently execute these actions into any kind of network segment, any kind of domain, any kind of whatever that we have in the ecosystem, in the 6G ecosystem, right? But before this to be done, we should verify that the actions to be deployed are policy compliant. We are defining policies, and these policies should be assessed. Once the policies are assessed, then the whole set of policies could be deployed, right? But this component is important. Let me now go into very quick into two key concepts that are the two roots for HORSE. The first is the proactive approach. So, as said before, we are not only working with a reactive approach. Instead, we are going for something that is much more appropriate when we think on this highly demanding scenario, that is a proactive approach. The proactive approach is handled by the threat detector and mitigator engine that is putting together the ML, is putting together cybersecurity, is putting together digital twins, is putting together different algorithms that are creating to manage that. So along with the threat modeling, is creating this structure for the system to be proactive. And the second one is what I mentioned before on the impact analysis. What we coin here as the what if. The what if actually is a loop, and the sense is what would happen if an attack is happening, or what would be an impact, or what would be the impact in the infrastructure if this attack is really reaching out the infrastructure, right? Or what would be the impact if a specific action is to be deployed? So this what if loop is critical to understand that what we are doing in the network is reasonable. It's reasonable from the point of view of what the effects would be on the system if I'm deploying something. So we will not deploy anything in the network unless this anything is to be previously tested. And these are just some pictures showing workflows, model blocks, and how different things are managing in this what if. So, as I said before, we are working on as a proactive, but of course, we should also keep in mind that we are also detecting. So we are working on two contexts, the one that is detection and the one that is prediction. And we are showing here next slides is what we call as a canonical workflows that are identifying how the different components into the HORSE architecture respond or work within these different say cases, right? Look that in the prediction we have one that is threat prediction, and in the detection we have three because we say even that could be also done in the threat, in the prediction, in the threat prediction. But look that in the detection, what we're having here is that of course we detect, but then we're analyzing three different cases. The one that the life cycle that is generated is policy compliant. The second one is not compliant, and the third one is partially compliant because that could be also the case, right? So you go easy to that. I mean, we are in threat detection, and if we see at the orange marble at the bottom, we see that the life cycle is generated by the ABI. The ABI is also sending the policies to the compliance assessment, and the compliance assessment in this case is saying, okay, everything is okay, so you can deploy it. So then the ABI sends the actions just to those blue blocks into the architecture that are responsible for deploying, orchestrating, and deploying the set of actions. In the second workflow, we are the same, but here in this case, the assessment is not okay. So in this case, the IBI, the intent-based interface, should generate another life cycle that is then checked again for the compliance assessment, and is then saying, in that case, we only keep two loops just to make it just illustrative. But the idea is that once the assessment is okay, you can deploy it into the blue box. Look, that this is something that is time consuming. I mean, we are generating a new life cycle, right? So it's not something that is immediate, right? And that's the case where we also consider the partially assessment, right? Partially compliant, because in this case, what we're doing is not creating, or what we're proposing is not to create a completely different life cycle, rather to go on a redefinition of the one that is already there, right? So once the policy says that the policy compliance says that the assessment is partially okay, we redefine this life cycle, right? Look that in this case, we're talking about threat prediction. So the block that is responsible for detecting is the demo. Now, if we're moving to prediction, look that the blocks that are responsible for predicting is the early modeling and the sandboxing, that are the ones that are running this emulated context. And in this emulated context, you can predict if something is about to come, right? Okay, on the demo, I said before, what we had in the project initially is two real use cases, one on transportation and the other one on XRBR, one on FSEC transportation, FSEC in Portugal, and XRBR in all in Germany. But we realized, as we are moving on in the project, we realized that I mean, it would be not so easy to show the different components and different functionalities that we are including in the horse architecture just to be shown with these two use cases. And just to indeed for this sake of illustration, we added additional use cases, and these additional, call it demos, are first from 1 to 8. That it starts, for example, it covers, for example, from attacks that are well-known attacks, as Felicia was saying before, but also on attacks that are specific to components that are included in the architecture. So the idea here is that we did not only provide an architecture that is a set of logs, say, hey, you can manage security by just managing the set of logs, but of course, this set of blocks and the technologies that are embedded may also be vulnerable or may also add vulnerabilities into the system. Just to prevent that, or just to keep in mind that that may happen, we also, for example, analyze the cases that in the digital twin you have some problems with the data. So there is a use case, there is a demo here. Or also, for example, that we have a mean in the middle in the connection that we have with the IBI, just to show that we are also considering how the different vulnerabilities that are included by only adding the horse components may be also managed by the system. And also we added the zero demo that is just one that is only showing how the system works. I mean, no worries on how security is provisioning. The only thing that we are showing here is how the system interacts, the different models in the component, in the different models and components in the architecture are interfacing themselves, communicating, and they work, right? So we did that, and this is working. Also, we should keep in mind that from the point of view of the validation, we did not use only simulation context, right? We actually use 3 testbeds that are provided by partners in the consortium. One in Kinit, another one, this one in UPC, and this one in UMO. And the idea is that by deploying different use cases into the different testbeds, we are, say, avoiding the case that we think that something is just particularly customized to run in a specific infrastructure, right? Actually, we are also having testbeds that are connecting themselves just to show that we even can manage different infrastructures from different locations and different testbeds. So in short, summarizing, in Horse, we are providing as, say, key innovations, this proactive approach with the sandboxing and with the detection and the sandboxing. We are also providing the what-if loop with early modeling and the sandboxing. We manage both early detection and prediction, and we have a very, say, credible validation strategy that is even extended from what we signed it or we initially was included in the project, with additional demos just to facilitate global understanding. And that's it. Thanks all for attention.
Thank you so much, Xavi. For the next presentation, I would like to invite Jose. Jose, you're here?
Yeah, sure.
I see your mic open. Thank you so much, Jose.
Let me put my screen on. Okay.
If it's okay for you to turn on the camera.
Okay, yeah.
Thank you so much. And I would also say, because Lisa had joined earlier, so she will not share her screen. She said that you
I can do it.
please continue sharing. Okay,
Yeah,
perfect. Thank you so much. Thank you.
Sure.
It's not in full screen yet.
Yeah, I'm in the process. So now it should be, right?
Yes, thank you. Perfect.
Okay, so hi all, I'm José Manuel Manjón from Telefónica. I'm going to talk a bit jointly with Elisa from Holo about how we have validated this horse platform in some demos, and specifically in the HoloLite use case that we have developed in the project. So in this slide, I'm presenting the scope of the integration and validation activities for the host platform. So first, we focus on the development of the IBI component within the host architecture, which is a central component of the platform responsible for translating the high-level intents into a concrete security workflow over the 6G infrastructure, and also provides a dashboard, which is the actual status of the attacks and the mitigation that we have in the network. Next, we also identify and characterize a set of KPIs that allow us to objectively assess both the applicability and overall performance of the host platform in our different scenarios. So building on that, we define and apply a clear methodology for integrating all the host components and moving from a lab prototype to a fully operational proof of concept. So with the architecture and methodology in place, we design a coherent demonstration strategy based on two well-defined use cases, which are the pilots where the main host benefits in terms of security, automation, and resilience. These use cases also connect with testbeds for validating the platform through dedicated demonstrator that stress its key capabilities under conditions close to the real deployments. And another essential aspect is the exploitation of the results. So we systematically collect and analyze and use all the data produced during this validation in order to fine-tune the AI models, the orchestration policies, and the security mechanisms in an iterative way. Finally, this whole cycle of the integration, demonstration, and feedback leads to the final release of the host platform, ready to support the future 6G environments and to feed the standardization and industrial uptakes. So in this slide, I'm illustrating the structured pathway that we have followed to achieve the final integration of the host platform. So this journey is divided in 4 stages, each one building upon the previous one. So we begin with the task forces phase, where we focus on clustering and organizing 2 or 3 core modules of the platform, while simultaneously defining the interfaces, which are the critical inputs and outputs that will allow them to communicate effectively. So once those foundations are established, we move into the demonstration phase. Here, the individual modules begin to interact and exchange real data in the real conditions. So we show tangible results through videos and live demonstration that prove the technical feasibility and showcase how the system behaves under the realistic loads. The third stage is the use case integration. This is where we bring together all the modules that we have developed and begin testing them against the defined use cases and their associated statement. In this phase, ensure that every component works not just in isolation, but also as part of the complete host ecosystem. Finally, we reach the final integration, where all use cases in the complete host platform are unified into a cohesive production-ready system. At this point, we have a fully validated platform ready for deployment and for supporting the future 6G networking. And each stage is essential, and each one depends on the successful completion of the previous one. So this methodological approach ensures that we deliver a robust, well-tested platform. So in this slide, just to show how we started with the integration process in the project. So for that, as commented, we cluster by groups of 2 or 3 modules the architecture of the project. So by doing this, we can check the specific interfaces between the different modules and check for inconsistencies before going further into the project. So we first needed to clarify the concrete information that each module needs and how it will be delivered to the following one. So by splitting the architecture, we can easily identify some initial gaps between the modules integration, and we solve them at the very early stage of the integration work. And as Xavi commented, then we step into the final demonstration. So these are the set of POCs that are focused on specific attacks and involve all the modules of the platform, acting in the different testbeds that we have, by the EU-Move, UPC, and CENIT testbed. So the set of attacks we have considered, and some like the video was ones, like MTP, DNS, API exposure, in the middle, and so on. So here we have also the Hello World demo, which is showcasing the interaction of all the host modules in the 2 workflows that we have considered, the prediction and detection. And finally, we also have included the 2 use cases of the project, showcasing the integration of the host platform with the specific components. So we will see in some minutes an example of the HoloMan. And this slide highlights the key integration contribution for the host project's approach to deliver a full platform. So one contribution is the establishment of a common topology that bridges real world and digital environments. So we do this by creating 2 parallel tracks. On one hand, we translate the real deployments into concrete testbed where we can conduct rigorous testing and validation. On the other hand, we build emulated environments that are the network digital twins, that are the virtual replicas of the actual network that allow us to experiment safely at scale without disrupting the real infrastructure. Second key contribution is the data generation within the testbed. This is critical for training and validating the AI-driven security models. We leverage the real equipment and servers deployed in the testbed to generate authentic network traffic, security events, and operational patterns. So this ensures that our platform learns from realistic to data rather than synthetic scenarios. And finally, the third major contribution is the IB dashboard, which attack lifecycle visualization. So the IBI, which is our intent-based interface, provides to the operator with a comprehensive view of the security threats and their progression through the complete attack lifecycle. This dashboard translates complex security events into actionable intelligence, enables swift and informed decision making. So now I'm going to pass the floor to Lisa, that will go deeper into the Holo use case that we have developed in the project.
Hello, everyone. I'm Lisa Joyce from HoloLite, based in Germany. We are an XR software company, and the use case is about the XR multi-user session, where 2 or more users from different locations can interact in an XR session, where they can talk to each other, they can interact with a CAD model, and review designs and models. So one of the images that you're seeing is where people are using different devices. So the use case is also device agnostic. So here the 2 users are in the same place, but not necessarily they need to be in the same spot. They can be in different places, and they will be shown to each other as avatars. So in this use case, we are focusing on users in different places where they are looking at each other through avatars. And a cyber attack is going to disturb the movement of the avatars, which is going to affect the session itself. And Horse is going to mitigate the attack. I will go through the application itself, and I will describe how the use case is structured. So the core of the use case is an application called HoloLite Space. It is an immersive design and engineering review tool for complex CAD data. The user can import high polygonal CAD models and interact with the parts or for prototyping or review. So instead of making a whole realistic prototype, which is costly, which is time intensive, you need to only make the design and do the review, and the last step would be the actual prototype. So this tool has found its user base in manufacturing industries like car manufacturers, motor industry, and construction industry, and defense industries, where they try to make machines, and as well as educational purposes, including training and ergonomic tests. So the solution is scalable, safe, and economic, and user-friendly. So the backbone of HoloLite Space is HoloLite Stream. So Stream is a software development kit, and it is a remote rendering solution that enables real-time streaming of entire AR or VR applications. By offloading the rendering on powerful services, HoloLite Stream bypasses the limitations of mobile devices and adds data security by not sharing the data with the mobile devices. So the mobile devices like HoloLens 2, MetaQuest, or all the other devices that you're seeing these days, they have native applications and the computing power is low. And this causes the problem for industrial use cases, where you cannot look at very detailed images and you cannot interact with less delay. So here we have HoloLite Stream, which is hosted on a server, and the entire application is rendered on the server. And we call the mobile devices as the client devices to which the HoloLite Stream renders or streams the entire application, and the user's data, the user input, the head pose and everything is streamed back to the server. So this enables a device agnostic approach, irrespective of whether it's AR or VR. One user can be using an AR device, another user can be using a VR device, and another user can be even using a desktop application. So they all can interact with each other in the same session. Can we move on to the next slide? So here I can show you the difference between the native application and the streamed solution. So on the left side, you have an engine on the top and a car at the bottom, which is from the native application. You don't see so much detail, and it is not useful for an industrial use case. And on the right side, you see the images of the Raptor engine, and at the bottom you see a car, which is highly detailed, highly polygonal, with high fidelity, and you can interact with each parts. You can explore through each parts and review the design. And next slide, please. Next slide. Yeah, okay, thank you. Here is the architecture of streaming. You have two parts in this. The left side is called the server, and then the left pocket is called the server, and the right pocket is, we call it the client. And there are two instances of the same application in the server as well as in the client, and everything is rendered on the server, streamed to the client. So the server can be a computer, a VM, any physical device for that matter, and we have certain hardware requirements, and all the data from the server application is streamed to the client device, which can be a HoloLens 2, a Quest, or any desktop, like mobile device. And we're coming to the use case. Here you're seeing the users from different locations. Here they see each other through avatars. And for this solution to become scalable, we need to virtualize the application by hosting it on a cloud. We are not in threat when we talk about the streaming between the server and the device, but when two servers have to talk to each other, that is where when we are in trouble, because in a multi-user session where people are in different networks, different areas, the servers have to talk to each other. So in this use case, the security for sensitive data is very important. For example, a design of a car of a company which is shared through a session, it cannot be tampered, or a customer interaction should not be disturbed by causing a delay. And Horse infrastructure can help us in this use case by identifying and defending such attacks. Move on to the next slide, please. Yeah, here you see the architecture flow. You already saw different components of Horse, the smart monitoring, pre-processing, DEME, EPEM, and the CNIT testbed that Jose just talked about. And you have a network exposure function, which is being attacked by an attacker here, and you can distinguish in the picture the normal users and the attacker. We will see a video here where we go through the entire use case and the API exposure overview. Jose, can you play the video, please?
Okay, let's try to put the video. Let me know if you can hear it, please.
We don't hear it.
You don't hear it?
No.
Okay, so we need to activate the sound somehow. So
I think you have to reshare it and say that you share it with audio.
okay, let me share again. Can you see the presentation again?
Yes.
Okay, let me know if you can hear now.
No, I don't hear.
Okay. So maybe it's because, yes.
Future of collaborative 3D design.
Now it's okay?
Yeah.
Okay. So I'm going to start the video.
Experience the future of collaborative 3D design and extended reality, powered by the Horse Project. Horse supports HoloLight, an extended reality software company, by enabling secure remote rendering for XR collaborative sessions. HoloLight offers HoloLight Space, an XR engineering application designed for visualizing, interacting, and collaborating on original 3D CAD data in AR and VR. HoloLight Space is powered by HoloLight Stream, proprietary XR streaming technology that offloads rendering processes to local servers or the cloud, allowing for high-fidelity XR experiences on a variety of devices. We are now witnessing a multi-user XR session in HoloLight Space. The scenario involves two users from different locations, represented by avatars, collaborating in a shared virtual environment. They can interact with 3D objects and communicate with one another in co-design in real time. This use case requires high bandwidth and low latency. When this solution is scaled and used to share classified data, the session is vulnerable to cyber attacks. Such a session can be disrupted by avatar jitter, communication delays, and poor user experience. In such critical situations, Horse Network Infrastructure empowers the users with continuous network monitoring, cyber attack prediction, and mitigation, and enables real-time, smooth, and uninterrupted XR experience. When an attacker makes requests to the NEF component of a 5G network to access or manipulate data, the repeated requests in the log is detected by the smart monitoring component. The pre-processing component collects and analyzes the data every 2 minutes and groups the IP addresses for specific requests and sends the data to DEMI. The DEMI component detects it as a threat and sends the information to the EPEM dashboard. The dashboard displays the risk levels from each IP source. When the EPEM detects an IP source with high risk, the firewall is triggered to block the IP address temporarily. Horse infrastructure continues to monitor the user requests, and if the abnormal activity is reduced, the IP source will be unblocked. The same IP source is allowed to make requests again when the threshold of high risk is not reached. This continuous monitoring protects the users from malicious activities while preventing false positives. With the involvement of Horse, HoloLight is able to run multi-user sessions with smooth user experience and secure data streaming. The users are able to work together on a CAD model and interact with each other. With Horse, HoloLight sees great potential in scaling up the technology securely.
Thank you so much. If you have questions, you can come back. I think Jose will close the topic with a conclusion.
Thank you, Lisa, for the introduction to the use case. So just to conclude, this final slide is summarizing the core conclusion of the integration of the Horse project. So first, the Horse delivered an integrated ecosystem where the intelligent security policies, AI-driven decision-making, and real-world validation converge seamlessly. So all these elements work together to create a cohesive platform. Second, the structured integration methodology we have followed ensures that every component is carefully developed, tested, and validated before the integration. So this approach guarantees a technical, robust, resilient platform ready for deployment in critical environments. And finally, the integration with the Holo XR use case provides a concrete proof that Horse can support critical application demanding ultra-low latency and end-to-end security orchestration. So this validates that our platform is not just a theoretical thing, but capable of delivering the performance and security that is required by industrial immersive application. So we can go from remote VR collaboration to real-time data that visualization in industry environments. So thank you all. This is all regarding the integration and the demo strategy we are following in the project. Now I think I pass the floor to Fabrizio again.
Thank you so much, Jose. We have a short round of question and answer. At this moment, we don't have any questions in the chat, but if there are questions from the participants, you can just raise your hand and then ask. Otherwise, we will go right away to the final closing. I think the presentations are very, very good.
Yes, I think in the interest of time, we can move on to the
Yes, we
conclusions.
should be
By the way,
closing.
if anyone is interested, you can contact us. You have the references. So I think we can just make, I have a few final remarks. So let me share the presentation. Do you see it?
Yes, yes,
Okay,
Fabrizio.
perfect. So a few final words. Since someone might ask, okay, what is the final outcome of this project? What will remain, let's say, in the scientific community? How we changed the and contributed to 6G security. So I have a few slides to close about some events that we organized in order to discuss about our results with the scientific community. And here you see two of the main events that we organized. We organized a workshop at ICC that was called The Path Towards 6G, Standardization and Research Vision, where we had the opportunity to discuss with experts from industry, academia, and standardization bodies about how to impact and to present our preliminary result at that time in order to show the feasibility of our approach. And also 1 month ago, we technically sponsored IEEE NFV SDN conference, that is the biggest event in network function virtualization and software-defined networking. And also at that event, we organized a special session on security in 6G and network digital twinning. So here are a couple of examples of events where we tried to bring the community together and discuss about our results, and I think they were very interesting. And also, we had dedicated webinars on specific topics. For example, Lisa also and other colleagues from HoloLight and from CNIT presented a demo at the ETSI Security Conference in Sofia Antipoli a few months ago. And also tomorrow, we will present some results of the HORSE project in an event where all the SNS JU projects in security and trust will discuss about their achievements. So we tried to do something that would remain as a contribution to the scientific community. And if you are interested, probably one of the best ways to also check the results of our, but also other project is to check out this white paper on 6G security and trust from SNSJU that collects our contributions, but also a lot of other projects that are working in cybersecurity and trust. And finally, we also contributed to standards. And the way we did it is through a presentation of a demo of the HORSE concept to the Zero Touch Service and Network Management event that was held at the end of November. And Telefonica was the partner of HORSE that presented this demo. Where we tried to demonstrate especially the functionalities of prediction and what if that are possible through the integration of digital twins. And also, we contributed to another white paper from ETSI, from the Experiential Network Intelligence Working Group, that is white paper number 4 that you see here on the right, where the purpose of this white paper was to discuss about how to use AI in order to increase network automation. And the contribution of ours was to show and demonstrate how network digital twins can be used, especially for security, but also for closing the loop of network management. So to close up, I would like to thank all of you for attending this seminar, and especially our partners for the effort and enthusiasm that they put in our project. I'm very proud of having led this initiative. But more than the partners in terms of companies, I think it's worth it to thank the people, because also from the social viewpoint, it was a great experience to interact with so many experts from companies, academia, research centers. And here you can see the photo from our last face-to-face meeting in Oporto, hosted by EFASEC. So with this, I would like to thank all the people that attended today and all the people that participated in the project. And I look forward to remain in touch with you. And you have our media information, so feel free to contact us if you are interested in more information. Thank you again, and have a good day to all of you.